So in this video, what I want to talk to you about is restriction endonucleases, specifically how to pick the correct one for the plasmid that you're working with. So I have a pretty busy plasmid here that's got several different restriction sites, and I've labeled a couple of other important components of the plasmid. Here we have the ori of the plasmid, here we have kanamycin resistance, here we have the promoter of the plasmid, and then here is the gene that we hope to actually cut into to put our insert into this particular plasmid. So let's go ahead and take a look at a couple of the different types of restriction enzymes that we have here, and let's talk briefly about why some of them are better choices than others. So your goal ultimately, when you're trying to cut your vector, is to only cut out portions of this part of the vector. That is the gene or site where you want to put your insert. Okay? So notice, EcoR5, EcoR1, BAMH1, and XBA1 all have restriction sites in that, which makes them seem like potential candidates, until you start looking at a couple of other key aspects. Notice with EcoR1, there's an issue. While I can use it to cut here, and that would be okay, if I use EcoR1, I also will cut the plasmid here. So even if I do a double digest, what I'm going to wind up cutting out is not just a portion of my gene of interest, or in this particular instance, the site of interest, but I'm also going to potentially cut out the promoter that I would need to express my insert. Okay, let's go ahead and use BAMH1 as an example. Okay, if I cut here with BAM, again, I cut into that site where I am interested in putting my insert, but I also cut over here. And that's a problem because I can effectively cut out both the promoter and kanamycin resistance. So that's a problem. So the only two enzymes in this example that would be the proper enzymes to cut with are EcoR5, which would cut here, and XBA1, which would cut here. When I cut with those, I would effectively cut out that region and that region only on the plasmid, leaving every other aspect of the plasmid intact. So when you're looking at a plasmid and you're looking at the different endonucleases, it's really important to make sure that when you create a cut in the plasmid at one location, it's not accidentally also cutting the plasmid at another location that may cause complications.